Hello class, how are you doing? I'm going to have a short video regarding differential. The very two famous books that mostly they use either Briggs or Larson, multivariable calculus. On Briggs is chapter 15.6, Larson is 13.4. And every time I see the word of differential, something comes to my mind, which is a difference. And somebody asked me, what is the difference? Well, I have $10. I spend $4. I have $6. That's the difference. Somebody said, what is $10 minus a $3? Well, it's $7. These are easy. First grader can do it. But sometimes I have $10 and a dime, and I subtract $6.04, 40 cents. How much is it? Well, I'm tired to think of it. I consider this one 10, I consider this one 6, because it's less than 50 cents, and I said approximately $4. That's good, it's possible. But somebody said, really, you approximate it. I need the exact. If you really want the exact, then you have to subtract and say 4 from 11. How much is 4 from 11? $7. 7. And 7 from 10 is 3. If you really want exact, it's $3.70. I said, only for 30 cents you crying? Let's do the easy one. Why you want to do this one? And your friend said, as long as it's plus minus 10 cents, you can approximate. More than that, I don't like it. And I said, yes, that's true, but we do the same thing in calculus, that sometimes when we want to find the change between two quantities, and those numbers are so ugly that sometimes we do approximate instead of finding the exact. Therefore, every time I ask you about the exact change, I use the word of delta, uppercase letter D. But if I said use approximation, use the lowercase d. And this is exactly what differential is. Differential is approximate the change in some y values. I don't know if that y is a difference between two quantity money-wise, maybe force. You push somebody to the left, some friend of yours is going to also help you. What is the difference between the two forces, the two pressures? What was the difference between the temperatures an hour ago and now? That y value could represent many quantity in physics or in businesses. And somebody said, how do you find the approximation? Okay, let me talk about exact. You have f of x equal to x squared plus 3x. What happened if your x is go from 1 to 3, and I said, what is the exact? You said f of 3 minus f of 1. That's exact. And sometimes instead of f of 3, we write x plus delta x, and f of 1 is f of x. And we call it the exact change in y value. Then if I put 3 right here, that's 9 plus 9 is 18. 18 minus, when I put 1 in here, let's make it a 4. That exact change is $14. But your function is always not that pretty that you can find the changes very quickly. Let's find the easy way. I'm going to start with the easy function, then you can apply the more complicated function. Let's assume this is a function, y equal to f of x. And you're going from that point to that point, and this is, for example, how much money you have in the bank this month, and how much money you have in the bank next month. And somebody asks you, did you spend some money and your saving went down, or it was increased? You said, no, my saving got taller. And they're going to say, by how much? You said, exactly by this. And you tell them, go look at this number line. If this one is 10 and if that one is 15, it changes by $5. But somebody said sometimes this number is 10.105. This is 15.231. And it's hard for me to find that exact. Would you find me an easy way to not the exact, but approximate, but my approximation be pretty much close to my exact? I said, you always have to change your complicated function to an easy function. And the easiest function in mathematics you can find is a line. Because usually you can find the difference between two y values. Therefore, you go to that first point and you find the derivative of that function. The derivative of that function, by having the point x, you can put them into the function, find the y value. Therefore, you have a point. And by taking the derivative and replace the derivative by the x value, you have the slope and write the equation of the line. And instead of using that black function which is complicated, use that pretty red function which is a line and say the difference between this point to this point, if the distance between them is delta x, is this much right here. But somebody said, man, you really overestimate, because instead of coming up to this point, you went up to that point. And that became my change. I said, I know, I overestimate. But what happens if that delta x approaches 0? That number, and that number is really approaching to the exact. Therefore, you better say, this one is the change in the y value from the first one to the second one, but it's to the tallest one. And you approximate. This one is the slope of the line, and this x, the difference between these two is delta x, but that delta x is the same as for the black function and the red function. For the black function, I put delta x. For the red function, because I'm overestimating, I'm going to put dx, and this distance for both of them are the same. Therefore, in here, instead of delta x, I can put a dx, and this is called the approximating the change in y value using a tangent line. This is called approximation. Therefore, somebody said, okay, what was the change between these two numbers? $14. But what happened if I go and said, what is the change between those two numbers from x equal to 1 and to 1.005? That's all I want. I want to go in the neighborhood of 1. I don't want to get far away from that one, because if you get far away, your estimation is going to get taller and taller and taller, or shorter and shorter and shorter. You overestimate or you underestimate. I want to get in the neighborhood. You either go a little bit to the right or a little bit to the left. I said, okay, that was it. F prime of x dx. But give me the function that you want to find the approximation. I'm going to use that function. Okay. This one, f of x, is at the exact neighborhood of a starting point. Therefore, in here, you have to say, I'm going to start from 1, and I'm going to find out the derivative of that function, which is 2x plus 2. Find the derivative at the point of x equal to 1, which is 2 times 1 plus 2, and that's the 4, that's the slope of a line. But plugging 1 in here is not hard. Plug 1 here and find the y value at x equal to 1, which is 1 plus 2 is 3. Right now you have a point and you have a slope. You write equation of the line. Y minus a y1 equal to m times x minus a x1. But the question is, that's the equation of a line, your tangent line, which is 4x, your x1 was 1, that's a negative 4. When the 3 go to the other side, big negative 3 go become a positive, negative 4 plus 3 is a minus 1. That's the equation of your tangent line. But all I need is the slope. For your differential, all I need is the slope. And what was the slope? 4. And I need the delta x. What is your delta x right here? What is the change between these two distances? 0.005. And what is 4 times 5? 20. How many decimal places? 3 decimal places. Therefore, the change in y value is 200. So simple. I need the slope. When I have the slope, I have f prime of x, and dx is already, you can find it from the given information. But if you don't know how to use this, you got to go in here and say, what is the y of 0.1, which is 3, and what is the y of 0.1005? Okay, you tell me what is this. Okay, I don't have a mind to do it. You give me that answer. You know I cannot do it in my head. I'm trying to find me a calculator here, to use a calculator and see my easy way. What was the difference? Therefore, I go right here and I'm going to say my function was, forget about the function, I'm going to use just like that one, and I'm going to put open parenthesis 1.005 squared plus 2 times 1.005, and that become 3.020025. And what was y1? Y1 was 3. I subtract 3. What is the difference? Oh, the exact change is 0.020025, and my easy way was only 0.2. Do you want to go through all that trouble, or you just want to find the slope and use differential to approximate as long as you are in the neighborhood? That's what you learn in Calculus 1. But the question is here, what happened if you are in Cal 3? Because your z is a function of x and a y, and that become x squared y plus 3y squared minus a 5x. I made that one up. And at the point of 1 and 2, I'm going to the point of 1.01 and 2.001, and I want to know when I go from here to here how much my z change. Oh, in here, unlike this one, I have a change in y, and also I have a change in x. But over here, I had only changed from x from 1 to 1.01. That's a single variable. I only change in x. And in here, the change in x was 0.005. But in here, I have change in both of them. Therefore, when it comes to here, you have to call it, I'm not looking for dy. I'm looking for dz. and my z depend to both of them, and I'm gonna call it total differential. Total means the change causes by the x, the change causes by the y. Therefore, I need two differential, because two, one of them gonna be the partial derivative with respect to x times dx. That dx right here is 0.01 plus partial derivative of y times dy. Therefore, if you go to that point and say, what is the partial derivative with respect to x? I'm sorry, is 2x y minus a 5. That's the partial derivative with respect to x times dx. What is the partial derivative with respect to y? Is x squared plus 6y times dy. But what was your target point? The point here you use to find a slope of a tangent line. Over there, my target point is 1 and 2. Therefore, what is the total change of the z around the point of 1 and 2? What is 2 times 1? 2. 2 times 2 is 4. 4 minus a 5, negative 1. What is the change in x? Sometimes it go down. You have to put minus. If this one go to 0.09, your delta x is negative here. But in here, your delta x changes by only 0.01. Plus, what is 1 square plus 6 times 2 is 13. And how much is your dy? The change in y was 0.001. As long as you are in the neighborhood of 1 and 2, that approximation is very close to the exact. And look at how easily I can do this. 1, 2, 3, 1, 2, 3. And all I have to do, say 0.013, 0.01. And that becomes 3, that becomes 0, that becomes 0. And the changes is going to become, oh goodness, when you subtract it right here, the change is going to become 0.003. And they call this one the total change. The changes that causes by the change in x and change in y. Therefore, please remember, from today in multivariable, we have total differential, and also in the single variable, we have differential. And I'm going to give you in the next video an application of it very quickly.